Meaning standard access list, cut over packet traces so I can give you. I'm gonna go ahead and drop those as to how they change the game from the CCNA to the CCN. Alright, so here we are with another episode of I Think I Know Stuff. It's your host Lamar, and I've been thinking, I know it's been a while since I released a video, but I feel like this way that I'm about to explain would be a better way for me to more efficiently address you guys. Since I'm going about this as I study and I share my knowledge, my newfound knowledge, I feel like it's better I show you my labs every day and you guys figure it out along with me, instead of me doing how-to videos and have to be so accurate in every statement I say. This allows me to learn and make mistakes as well as you learn, and we all figure it out together. Get you guys more involved in the comments as well. So with that being said, I'm going to try and drop a video every day, or at least record a video every day and drop at least 2 videos a week, and move forward with that with my CCNP routing test coming up very soon, here in like 3 weeks. It's going to be a lot of stuff to cover, a lot of stuff for you to grab, a lot of stuff for me to retain and explain. But for today, today's topic would be IPv6, which you can see here on the screen. I'm going to go over a couple of ways to assign IPv6 addresses to these 3 switches. Routers, should I say. Never mind the names. Could have picked a better naming convention, but I'll go ahead and change that in a few seconds. But the 3 that we're going to work on would be auto configuration, EUI64, and static configuration. Let's start by explaining them. Auto configuration is a mixture of a couple of different ways just to put together IPv6 address, which is it uses DHCP, so it's very similar to DHCP. It learns its prefix from a DHCP server and gets its, it learns its prefix from a router or whatever connected device, and it gets the DNS from DHCP and so on and so forth. Whereas EUI-64 is when you give it the prefix, you give the interface the prefix, and you tell it the prefix length, and you tell it EUI-64, and it takes that MAC address of that interface and turn it into 64 bits. So most of the time, you give it the first 64 bits of the IPv6 address, and it takes the MAC address and does its computations or calculations and creates a 64-bit ending of the IPv6 address. And besides that, we also have static address, which you statically address or manually address the interface with a full 128-bit IPv6 address. And that's one of the things I should have said from the beginning. Unlike IPv4, IPv6 is 128 bits, which means it gives us way more IP addresses just to use, which is kind of why we're moving that way towards IPv6. But anyways, on to the configuration. Let's start by giving our main router, which would be this router here. Let's start it up. I'm going to go ahead and give it a name. Let's call it HQ, and we're going to start by implementing IPv6. Alright, so I want to begin by saying I am sorry. I just did about 10 minutes worth of video and realized I was not recording my screen at all. But so far here on HQ, as you can see, I changed the name to HQ and began by entering configuration mode. And the first thing you want to do with IPv6 is enable IPv6 unicast routing. Here you have IPv6 unicast routing, which is the command you want to use. No matter what you configure on the interface, without this, you won't be able to actually use IPv6 on the Cisco device. After that, we want to enter our first interface, which would be FA0/0, which I entered here. You can see here on the screen. And we're going to use EUI64, with this, you can see that I have the first 64 bits of the IPv6 address here. And while I have this here, I want to go ahead and quickly explain, as I was talking about earlier, abbreviating IPv6 addresses when noting them or even entering them in the device. You see here in this fourth octet, you just have a 1. So with IPv6 addresses, you can omit preceding zeros, not the zeros that come behind any character, but before any character, you can omit them. As follows: in the following octet, we have double colon. Double colon, it can only be done once in a IPv6 address, so you can't do it in 2 spots in the IPv6 address without any errors. It just won't read the address correctly. But the double colon means that everything in between that is zeros. So there's no other character in between those 2 colons but zeros, and the router or switch or device, desktop, whatever it may be, will treat it as such with IPv6 addresses. But back to EUI64. With EUI64, I only need to provide the first 64 bits, which is the prefix, and I go EUI64, and it takes the MAC address, does the calculation, and creates the last 64 bits. Now it has its own IP address. Boom. Now we do an IPv6 enable just to make sure we have IPv6 enabled on the interface, and we have a link local address. Though in this example we won't quite need it, we just want to make sure that it's there and make sure IPv6 is running on this interface. Then we do a no shut. Never mind that. You see that I obviously fat fingered and forgot to space. But here we are here with the no shut. Now let's bring it down to where I went on to the next interface, which would be after we've seen the interface go up and down since there's nothing connected. It would be interface FA or Fast Ethernet 0/1. First thing we want to do is, I should explain, in this interface we're going to use auto configuration, which will require on the other end of this link a DHCP server. Normally it'll be like the ISP that's on the other end or something like that. With the router, since this is a router, it will be ISP on the other end, but it will be just another router from us, obviously, since this is a lab. You want to go IPv6 add auto configuration. Don't omit anything like me, obviously 2 or 3 times in a row, but here it is, IPv6 address auto config. And then we want to enable IPv6 here as well for that link local address and make sure IPv6 is running on the interface. And then we want to do a no shut. Boom. Now the interface is ready to run, ready to rock and roll. And we save our configuration and we move on to the next guy. Now see, we've done the EUI64. We've done the auto configuration. Now, next thing I want to get into, which is so simple, is the statically assigning IPv6 address, and I'm going to put it in the same subnet with that the first interface that we did, the EUI64, and we'll see what goes on there, which I'll show you. I'll type out the extended version as well as the abbreviated version, and you'll see it clear as day in front of your eyes and understand what I was talking about. Alright, so here we are in the other interface where I told you we we're going to go ahead and apply IPv6 static addressing, and this is what we're going to call branch 1. As you can see, I just changed the name here. We're going to go through the same steps as we did before as far as enabling IPv6 unicast routing first. Excuse that. Enter. And we're going to use interface Fast Ethernet 0/0. Boom. And like I told you, this one's going to be a fast, simple one. So you just go ahead and pay close attention so that you can follow along. First thing we want to do is set our IPv6 address. Just like IPv4, you go IPv6 address. Let me type it out this time. And I'm going to go ahead and show you the extended version of this IP address, which of course you're going to take the easier route after pass. Well, The test, I'm not even sure will make it mandatory to use either. But in the real world, you're not gonna want to type millions of characters if you don't have to. If the device gives you a shorter way, promise you won't regret using it. 2001 colon, and I believe we went 1234 colon AB. I'm sorry, CD colon 1 was the next octet. Now we have 64 more bits just to fill in. The extended version of this would be 0000 colon 0000 colon 0000 colon 0001. It's what I'm going to use for this interface. And slash 64, that's going to be our CIDR, or I'm sorry, it's not IPv4, but this is our prefix length. And this is, like I said, the extended version. No one in their right mind will want to type this out, right? So let's go ahead and tighten this up. By even, you can go like that. Boom. Or we can even take away those one or those zeros. Now we know this is the first device in this subnet, should I say. And enter. IPv6 enable. No shut. Boom. It's as simple as that. Link went up, went down. I'll go ahead and connect something real quick so that we can make sure that these are working. Show CDP neighbors detail. Boom. And this is our neighbor right here. So we're right now on branch 1, and this right here is the IPv6 address of FA00 on HQ. Let's go ahead and ping that, okay? So let's go ping. Gonna highlight and right click so that we paste. Now I bet you we have IPv6 neighbor. There we go. Now we can see the unicast address as well as the link local address of that interface. Now we have friends. We can ping between the two and they know each other. Now on to confirming or configuring and confirming the autoconfig. Alright, so here we are on branch 2. I've already went ahead and set up IPv6 DHCP. That isn't going to be part of the video. I'm not really concerned about that. I'm just concerned about knowing if auto configuration will actually be attainable right now in this lab, which I'm pretty sure it is. Like I said, you guys are riding along as I figure it out. All of these things are coming from what I read earlier today. Come home and study, and this is just helping me reinforce the knowledge as well as pass it along to you guys, my community. But anyways, let's begin like we did on the others. IPv6 unicast. Just tab it out. Routing. Boom. We enabled that. We're gonna go into interface FA0/1. Boom. We enabled that, and we're gonna give it an IPv6 address of 2001 1234 ABCD 2. And see, this is actually very similar to the previous IPv6 address that we used, but it's not going to be the same subnet. You see I got a 2 here instead of a 1 in this octet, and we're going to make it do a EUI 64 just like the other. And that's kind of what auto configuration will do. Once it gets the prefix from this router, it'll go ahead and generate the other 64 bits, because that's all it does. Grabs the prefix and then uses DHCP just to get the DNS, and boom, it's off to the races. But anyways, I'll save that information for later. And before we even connect the two, we can even check back in the HQ router just to show that it doesn't have an IPv6 address at the moment. But let's finish this configuration. /64 EUI-64. Boom. IPv6 enable. No shut. And that's pretty much all we have to do here for now. Let's go ahead and save this. Alright, so here we are back in HQ still at this moment, and I've connected the two routers. Let's go ahead and check and see what we have in our CDP neighbor details, just to see if we can actually see that other router as a neighbor. Make sure we can find the IPv6 address, and we'll ping that just so we can make sure we create that IPv6 neighborship or neighborhood. So we want to go show CDP neighbor. Yeah, well, branch 2 is definitely there. We can see it's connected here on fast Ethernet 0/1. Local interface fast Ethernet 0/1. Alright, that's correct. But let's do details so we can actually see our IPv6 address of that device. There's branch 1. Yeah, that's the IP address that we configured earlier. And here's that EUI-64. That's why it looks a little bit different. But there's the 2. It's fine. We're going to go ahead and go ping. We're going to highlight this IPv6 address. And we're going to paste that thing. We're going to ping it. We can reach it, which means we should have IPv6 neighborship. So let's go IPv6. Oh, I'm sorry. Show IPv6 neighbor. And we'll enter, and there we go. We have the other. It says stale because it just, it just started communicating. Oh no, I'm sorry. I was looking at the wrong ones. It says reach. It can reach these two, which is the global unicast or the unicast address of the newly connected DHCP router / ISP, or as I named it, branch 2 router. And we have the link local address here, which we both have obtained from ping, which is fine. But now let's see if we have an IP address here on our FA 0/1 of A. Now to actually see the IPv6 address that we got from this auto configuration, I'm back in branch 2, which would be the neighbor via IPv6 on that link. And if I do a show CDP neighbor details, we'll see the IPv6 address of that auto configuration interface. So let's start by doing that. Show CDP neighbor detail. Yes, I shorthand everything as much as possible. And here we are. We see that this is the IPv6 address of HQ. Just to make sure we can actually get there, let's go ahead and ping it, which obviously we can get there because we see it showing as CDP neighbor, but just to be sure, I'll go ahead and ping it here. And there we go, 5 out of 5. Seems like 100% to me. Hopefully I get that on this test. But anyways, that will go ahead and conclude our video today about IPv6. And tomorrow we're going to go ahead and talk about RIP and RIP-NG, or RIP Next Generation, which is RIP for IPv6. And since we already have IPv6 here, we'll just continue implementing each of these routing protocols and different subjects of the CCNP route on this very same lab. We'll just build upon it, and so that you guys can kind of follow along instead of just starting over every time you watch one of my videos. We'll just build upon this. But like I said, that concludes our review of IPv6 and implementing a couple of the different ways. That's not every single way of adding an IPv6 address to an interface, but here are some of the majority of the topics covered in CCNP for IPv6. Catch you next time on RIP-NG and RIP as a whole. We'll go ahead and talk very briefly about RIP and RIP-NG as a whole, and we'll go ahead and configure it. We're just after it. Every video, we're just going to be after it every day. And one more thing before we get out of here, I must remind you, go ahead and follow me on all my socials. I'll drop my social sites and my handles down below. And go ahead and like and share this video if you felt like it helped you in any bit, or if you know someone that can help. And tell everyone you know about me, because building community is what I'm all about. Helping you learn helps me learn, and we all learn together. That's great. That's what I'm all about. So let's go ahead and do this.